So previously we have discussed about the time weighted and money weighted rate of returns. We have discussed how we calculate the time weighted rate of return, the importance of internal rate of return, net present value, and the steps involved in time weighted rate of return calculations. Now we are going to start with a few key points where we actually have to pay attention when we are when we are calculating money weighted or time weighted rate of returns. So time weighted rate of return, when we talk about time weighted rate of return, it is not impacted by the timing of the cash inflow and outflow. So what does this means is the timing of the cash inflow and outflow. So timing of cash inflow and outflow, if you remember the example which we did, the timing of cash inflow and outflow is not impacted because uh, for every period we are calculating a different holding period return. And that's how we actually calculate time weighted rate of return. So we calculate holding period return for every period. And similarly, money weighted rate of return is not impacted by the timings and the amount of cash flows. So along with timings and cash amount of cash, money weighted is actually affected by this thing. Money weighted is affected, but time weighted is not affected. Please pay attention to this line. Time weighted is not affected by the cash flow, cash inflow and outflow, but the money weighted is actually affected by, it's impacted by, affected as well as impacted by timings and amount of cash flows. The second point here is in investment industry, time weighted return is preferred method of performance measurement because portfolio managers typically do not control the timing of deposit to and withdrawal from the account they manage. So in portfolio management also, time weighted return is actually preferred rather than money weighted uh, rate of return because for every transaction, the portfolio managers cannot control the withdrawal or deposits of the money in the accounts. So what they do is they actually calculate holding period returns for every period. So that's why money weighted rate of return is preferred when we are talking about portfolios. The third point here is if the funds are contributed to an investment portfolio just before a period of relatively poor performance, the money weighted rate of return will tend to be lower than the time weighted rate of return. What does this mean? So right before, if the funds are contributed to an investment portfolio before a period of relatively poor performance. So if the portfolio is performing poorly, but somebody invested money into that portfolio, so the time weighted rate of return, the money weighted rate of return will tend to be lower than the time weighted rate of return because money weighted rate of return is actually impacted by the cash inflow, the cash flow, and the timings. But time weighted rate of return is not impacted by the timing of the cash flow. And on the other hand, if the funds are contributed to the portfolio at a favorable time, just before a period of relatively high return, the money weighted rate of return will be higher than the time weighted rate of return. And this again is something which is complementing our first equation, first point. because money weighted rate of return is impacted. So if a fund is not if a fund is performing poorly, or if a fund is performing exceptionally, so this, if somebody invests or withdraws money in these kind of situations, so your money weighted rate of return will be impacted. Money weighted rate of return will be impacted, but your time weighted rate of return will not be impacted in these kind of situations. This is what you have to pay attention to. The fourth point here is that the use of the time weighted return removes these distortions and thus provide a better measure of managers' ability to select investment over a period. And the fifth point is manager has complete control over money flows in and out of the account. The money weighted rate of return would be more appropriate performance measure. And this is in relation to our second point. If the investment in the investment management industry, time weighted rate of return is preferred because portfolio managers typically do not control the timing of deposit to the withdrawal of funds from their account they manage. If the portfolio manager has complete control over the money flows into and out of the account, the money weighted rate of return would be more appropriate performance measure in these kind of situations. And this also complements the first equation, the first key point here, that money weighted is actually affected or impacted by the cash inflow and outflows, but the timings and the amount of cash flows, but the time weighted rate of return, the time weighted return is not impacted. But in a situation where you can control the flow of money, then you will prefer the money weighted rate of return, not the time weighted rate of return. So with that being said, let's start with our question and answers. So question number one. The question number one is which of the following is most accurate with respect to relationship of the money weighted rate of return to the time weighted rate of return? If funds are contributed to a portfolio just prior to a period of favorable performance, prior to a period of favorable performance, the money weighted rate of return will be depressed. No, this is wrong. We just discussed about this in our key points, where we need to pay attention to. Money weighted rate of return will tend to be elevated. Yes, this seems right. But the third option is time weighted rate of return will be tend to be elevated. No. One condition here is relationship of money weighted rate of return to a time weighted rate of return. And they have not mentioned this thing in the question. Can or cannot the manager has the complete control over the flow into and out of the account? If the manager has the control of flow in and out of the in and out of the uh, in and out of the fund or in and out to the account, so money weighted rate of return would be preferred. And because just contributed to a favorable performance just prior to a period of favorable performance, the portfolio, the funds are contributed, so this will actually impact your money weighted rate of return and it will be elevated. But if this was not favorable, uh, uh, so they have contributed or withdrawal the funds from the account right before bad performance, poor performance. So it will depress the money weighted rate of return. So option B is correct option. Correct choice for this question. Another question here is money weighted. We have to calculate the money weighted rate of return in this question. One investor buys one stock for $100. At the end of year one, she buys three more shares of $89 per share. And at the end of year two, she sells four shares for 98 each. Stock paid dividend of $1 per share at the end of each year. Uh, at the end of year one and year two, what is the investor's money weighted rate of return? So, okay, so we have before we use our calculator, we actually need to find out the cash flows first. And to find out the cash flows, we need to do some rough calculations. So at time t0, she purchased $100 worth of shares. So $100 is in cash outflow. At time one, so over this $100, she received a $1 dividend. And also at time one, she purchased three more shares. So she has purchased three more shares, three shares for $89 a piece. So 89 into 3, 267 at time one. This is the cash outflow. This is again a cash outflow. Let me just use some colors. So this is a cash outflow. This is again a cash outflow. This is a cash inflow of $1 here at time one. Now, at the end of year two, time two, she has actually received dividends. Now she has four shares total, one share from time zero, and now she is going to have a dividend of $4. This is in cash inflow of $4 from the dividend. And again, now she has sold all four shares. So this means she has sold all her four shares for $98 each. $392. So this is a cash inflow of $392 plus $4. This will be equal to $396. And this is going to be a cash outflow of 267 and $1 we added that. So this is going to be $266 of cash outflow in uh, uh, the year one, and at the year time zero, so there is $100 of cash outflow. So it's $100 of cash outflow. So if we look at our cash flows, so CF0 is going to be 100, CF1 is going to be 266. We have calculated how, and CF2 is going to be our 396. We need to calculate the money weighted rate of return. So we will calculate the IRR. And now let's go to our calculator and see how do we plug in these numbers into our calculator. So our first cash flow, we will go to cash flow. We will we plug in our numbers. So first cash flow is 100 negative. We'll enter 100. Then we will go to cash flow one. So cash flow one is going to be 266, a negative cash outflow, a negative sign. Then the frequency, let it be one. Then cash flow two. So cash flow two is going to be negative positive because we have sold everything. Now this is 962. This is going to be 962. We are going to plug in into this. We're going to plug in by enter. So it's fair. I mean, we have punched this thing into the calculator. Now we are going to press on the IRR. We are going to compute the IRR. The IRR is 3 point or 6.36. 36.36 percentage. So we do have a 6 point. 36 percentage. So this C is going to be our right option. I hope this is clear and you are able to figure out how we are going to calculate the money weighted rate of return. And again, in next question also, we have time weighted rate. We actually have to calculate the time weighted rate of return. And how do we calculate the time weighted rate of return? Let's uh, do one question here. So on January 1, Jonathan Woods invested $500, $50,000, sorry. At the end of March, his investment is worth 5,100. On April 1, Woods deposited again $10,000 into his account. And by the end of June, his account is worth $60,000. Woods withdraws $30,000 on July 1 and makes no additional deposit or withdrawal for the rest of the year. By the end of the year, his account is worth $33,000. So time weighted return for the year is closest to. Now, if you see, uh, Jonathan Woods started from January 1, from January to March. Just use a different color. So January to March. At the end of March, his investment was worth $51,000. So $51,000, this is going to be your holding period return for that specific period, minus one. So this is going to be, we'll calculate it later on. From April to June, his account is worth $60,000. And in between, he started from $51,000 and deposited $51,000. $51,000 and deposited $10,000. Minus one, this is going to be his holding period return for that specific quarter. Now from July till December, he did not made any withdrawal. On July 1st, he made a withdrawal of $33,000. And this actually impacted his $60,000. So $60,000. And we are going to subtract the end of the account money, $33,000. We're going to subtract one. So this is how we are going to calculate. This is pretty much simple. The opening, closing. This is the opening. This is the closing. Now the closing is going to change. The opening is different. The opening is different and the closing is different. This is the formula for holding period return, if you remember. The holding period return. Ending, beginning, cash flow, beginning. So we start from ending. We close at we divide it by the beginning value. So beginning value, when we are talking about the beginning value here, in this example, the beginning and the ending value. So these are the beginning value. The wood is invested 50,000. Yes. This is the beginning value. And the denominator, let me just write it somewhere. In the denominator, we are going to use the beginning value. And in the numerator, we are going to use the ending value. Now, understand this thing that the beginning value is going to change at times, and at times ending value is going to change. So Jonathan Wood invested 50,000. So 50,000 is the beginning value. It's in the denominator here. The denominator here, we are calculating the holding period return, HPR. So the beginning here, the ending here. At the end of the March, the investment is worth 51,000. So at the end of the March, the investment is worth 51,000. So from 50,000, he has reached 51,000. So 1,000 divided by 50,000. So this is what actually the formula does for us. This minus one does for us. So now for April to June, if you look at the question here, how we have solved it, how I have solved it. So Woods actually deposited 10,000. Now this is the beginning value on April 1st. On the starting of the month, April 1st, he deposited 10,000. So this is the beginning value now. So from 51,000, the beginning value is changed. 51 plus 10,000 here. At the end of the March, the investment is worth 51,000. It's here now. 51 plus 10,000. And at the end of the June, at the end of June, his account it was 60,000. So the numerator is the ending value. 60,000 is the ending value. The holding period return we need to calculate for this period. At July, when you look at the July numbers here, at July 1, he withdrew 30,000. Again, he withdrew 30,000 from his opening balance of 60,000. He withdrew 33,000 and no additional deposits or withdrawal for the rest of it. By the end of the year, his account is worth 33,000. So this is the ending value. This is the beginning value. Yes, it's a little tricky, but you need to pay attention. So now we are going to calculate these holding period returns. So for, okay, let me just share my screen and let's, uh, uh, since we are investing our time into this, so let's do it properly. So 50,000, 51,000 divided by 50,000. And I'm going to subtract 1. So this is 2%. So this is going to be 0.02. I will convert this into percentage, or this could be 2% here. Let me use a different color now. The another the another for April to June, it's 60,000 divided by 51,000 plus 10,000. And then we subtract 1 out of this. This is 1 minus 1.64%. And for July to December, we have 33,000. We are going to divide it. Okay, so these brackets are called parentheses. So we have divided this by, now we are going to use the parentheses function. 60,000 minus 33,000. Then we're going to press n equal to. So this is going to give me 1.22. Now I'm going to subtract 1 out of this. I think I made a mistake here. 33,000 divided by, okay, divided by 60 minus 33,000. 1.22 minus 1 into 100. Okay, I was calculating wrong numbers. 33,000 divided by 60,000 minus 30,000. So this is going to give me 1.1, and I'm going to subtract 1 out of this. So 10%. And multiply this with 100. This is going to give me 10 percentage. Now, okay. Let me just show you what we have the numbers as of now. So this is 10%, this is 2%, this is minus 1.64%. Now I'm going to plug these numbers into our uh, now I'm going to calculate this using geometric mean. So the final calculation is 1.02 into 1 minus 0.0164 into 1.1, again 10%. Then we subtract minus 1 out of this. Clear everything? One, okay, let me just subtract this thing first. 1 minus 0.0164. Now let's multiply it with 1.02 and multiply it with 1.1. This is going to give me 1.10. Now we subtract 1 out of this. We multiply it with 100. This is going to give me a final number of 10.36. So when we calculate everything, this all, so this is going to give me 10.36 percentage. So this is a multi-period holding return, and it's used. 10.36 is the right answer. So this is the multi-period holding return which we uh, studied here. No, okay, here. This is what the multi-period, when we actually have multi-period holding returns, this is how we actually calculate that. In LOS1B, we discussed about it. Okay, so now let's move to question number 4 now. So question number 4. Question number 4 is assume an investor makes the following investments. So today she purchased a stock of Redwood Alternatives for $50. After 1 year, she purchased another stock for $75. One more year, she sells both the stocks for $100 each. There are no transaction cost or taxes. The investor's required rate of return is 35%. During 1 year, the stock paid 5% dividend per share. In 2 years, the stock paid a dividend of 7.5 per share dividend. The time weighted rate of return. Now we actually have to calculate the time weighted rate of return. So when we talk about time weighted rate of return, we always calculate holding period return, HPR. So here the holding period return for time period P0, we started from $50. Then there was a dividend of $5. Then there was the price, additional stock they purchased is $75. So the holding period return, the beginning and the ending is the holding period return for holding period HPR1 is equals to, so 75. This $50 share is now for $75. This is what it means. So this investment of $50 is now worth $75. Yeah, we are going to subtract 50 out of it. We are going to add $5 of dividend, and initial investment was 50. So the first year, the holding period return is 60% after calculating everything. Second year's holding period return. Now, second year's holding period return is we started from $75, $75. One stock is of $75. There is a dividend at time two of $7.5. And the price of the stock at the end of the time is $100. So holding period return, HPR, for investment number two is 100 minus 75 plus 7.5. And we are going to divide it by 75 because this is our initial investment. So if we calculate everything, this is going to be 43.3 percentage. So first year holding period return is 60 and second year holding period return is 43.3. Now we have two holding period returns. What we are going to do is we are going to use the multiple holding period return. I am going to add it. 1 plus 4.43, and then we are going to subtract 1. 1.06 into 1.433 and minus 1. So this is going to give me 51.4, the approximate value for our holding period return. I hope you have understood the logic behind this. So it's little the time weighted rate of return, to calculate time weighted rate of return, it's a little tricky, but it's important so that you could understand how the holding period returns are actually used, how the holding period returns are actually uh, how the holding period return actually help us to evaluate the returns of a portfolio without getting impacted by the inflow and the outflow of the inflow outflow or the time of the inflow outflow. Okay, so question number five. So question number five is that an investor buys one stock, one share of a stock of $100. At the year end, she buys three more stocks of $89. At the end of 2 years, she sells all her stocks for $98. Each stock paid a dividend of $1 at the end of 1 year and 2 year. What is the investor's time weighted rate of return? So previously we did something like this, but here they were asking the money weighted rate of return. Now here they are actually asking for the time weighted rate of return. So for time weighted rate of return, again, we need to calculate the holding period returns. So holding period returns, we started from $100 at the end of 1 year. So just like we did here, so price is time zero. She bought a stock for $100. So $100 is the cash outflow. One stock for $100. At the end of 1 year, she buys three more shares at $89. So this means that her stock's value has actually fallen from $100 to $89. So $89 minus $100 plus $1 of dividend. And it actually started from $100. So this is going to be your HPR1. And this is going to be a negative 10% return for the first year. Holding period return for time two. Now at the end of 2 years, she buys 98. Buys a stock for $98. $98, and the stock paid a dividend of $1. And she initially invested $89 and started from $89 again. So this time it's giving us an investment, a return of 11.24%. And from this, it's pretty much simple to calculate the holding period returns. So 1 plus 0.1124 and 1 minus zero point 0.1. We are going to multiply these two and we are going to subtract 1 out of it. So this is going to give us our holding period return. Okay. Thank